Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Codes DTC, P219C, P219D, P219E, and P219F specifically refer to air-fuel ratio variations across the individual cylinders of the 2023 and later Honda CR-V models. Each code corresponds to a specific cylinder: P219C for cylinder 1, P219D for cylinder 2, P219E for cylinder 3, and P219F for cylinder 4. When these codes are triggered, it indicates that the Powertrain Control Module (PCM) has detected an abnormal fuel coefficient in these cylinders, suggesting that they are not operating efficiently. The PCM continuously monitors these ratios and compares them to specified ranges, logging an error if deviations occur. Addressing these codes is critical, as improper air-fuel ratios can lead to increased emissions, reduced performance, and potential engine damage. This guide will explore the diagnostic process for these codes to ensure proper resolution. The primary components involved in triggering DTCs P219C, P219D, P219E, and P219F include the air-fuel ratio sensors, the Powertrain Control Module (PCM), fuel injectors, and ignition coils. The air-fuel ratio sensors measure the proportion of air and fuel entering the combustion chamber, ensuring optimal combustion. The PCM is responsible for processing data from these sensors and controlling the fuel delivery and ignition timing. If the sensors detect errors in the air-fuel ratios, the PCM will store the corresponding DTCs, indicating issues specifically in cylinders 1 through 4. Fuel injectors are responsible for delivering the right amount of fuel for combustion, and malfunctioning injectors may cause incorrect fuel ratios. Similarly, ignition coils ensure that the fuel-air mixture ignites efficiently. Any failure in these components could exacerbate the air-fuel ratio variations. These components are located within the engine compartment, with the PCM generally mounted in the cabin or at the engine bay area. Several factors may contribute to the occurrence of DTCs P219C, P219D, P219E, and P219F. First, faulty air-fuel ratio sensors may not correctly measure the amount of air and fuel, leading to engine performance issues. Injector malfunctions can also cause inconsistent fuel delivery, resulting in variations in the air-fuel ratio. A malfunctioning ignition system, which includes the ignition coils, can prevent optimal combustion, further complicating the air-fuel mixture within each cylinder. Engine compression problems could also arise from low compression due to leaky valves or worn piston rings, which may affect combustion efficiency and lead to abnormal air-fuel ratios. Identifying the specific cause requires a thorough inspection of these components, including sensors, injectors, and ignition parts. When the vehicle exhibits symptoms associated with DTCs P219C, P219D, P219E, and P219F, drivers may notice a significant decline in engine performance. One of the most common symptoms is poor engine performance, characterized by sluggish acceleration and reduced power. Increased fuel consumption is another consequence, as the engine compensates for the incorrect air-fuel mixture, leading to economic disadvantages. Rough idling often occurs, where the engine exhibits erratic RPM fluctuations, making the vehicle feel unstable during stops. Additionally, the check engine light will illuminate on the dashboard, alerting the driver of existing diagnostic trouble codes stored in the PCM memory. Addressing these symptoms promptly is crucial in restoring proper engine function and efficiency. The first step in troubleshooting the DTCs P219C, P219D, P219E, and P219F involves starting the engine and holding it at 3,000 RPM without load. This initial step allows the engine to reach optimal operating temperature and pressure, ensuring that all systems are functioning correctly. After reaching 3,000 RPM, the engine should be allowed to idle until the radiator fan engages, which signals that the cooling system is operational and the engine management system is maintaining proper temperature. Observing these conditions is fundamental, as the engine's performance must be closely monitored during testing. Additionally, holding the RPM can help reveal any immediate irregularities in the engine's behavior or codes that the PCM may trigger in relation to air-fuel ratios. This setup prepares the technician for more stringent tests that will follow in the troubleshooting process. In the second troubleshooting step, once the engine is idling quietly, drive the vehicle at a steady RPM between 1,000 to 1,200 RPM. This RPM range is crucial as it replicates typical driving conditions while also putting stress on the engine and management systems. Following this, accelerate smoothly up to 3,400 RPM over a period of about 10 to 15 seconds while monitoring the engine's performance closely. Repeating this acceleration process multiple times ensures that consistent data is gathered, allowing for better diagnostic accuracy. Ideally, observing how the PCM adapts to changes during this acceleration can provide insight into potential air-fuel ratio deviations in any of the cylinders. If any variations are recognized during this process, it may bring to light the cylinders with abnormal ratios, guiding further inspection and repairs. The third troubleshooting step requires checking the fuel factor study value for each cylinder to identify if the readings fall outside the specified range of 0.82 to 1.21. The values represent the air-fuel mixture's efficiency. Thus, any reading outside this range indicates a malfunction. For instance, if the value for the particular cylinder related to the DTC in question is out of the prescribed range, the PCM can deduce that the cylinder exhibits a variation. It's vital that the technician selects the parameter item directly associated with the stored DTC to ensure accuracy during this inspection. This logic-driven approach allows for pinpointing issues to specific cylinders while also validating the PCM's feedback on its air-fuel target ratios. Evaluating these parameters is instrumental in confirming whether a cylinder's air-fuel mixture needs further assessment, or if other components, like the injector or ignition systems, might also require inspection. After completing repairs related to the DTC's P219C, P219D, P219E, and P219F, a final verification step ensures that all issues have been addressed effectively. This involves confirming that the repairs have rectified the air-fuel ratio variations by verifying that the affected components have been replaced or repaired appropriately. Following this, monitoring the vehicle's performance is essential, ensuring that it operates smoothly without any abnormal hesitations or irregular engine sounds. Also, it's critical to clear the related DTCs from the PCM to reset its learning parameters. This allows the module to reevaluate the vehicle's performance benchmarks without interference from previous fault codes. Keeping a close watch on how the engine behaves post-repair will help in identifying any persisting issues. This comprehensive final verification ensures that the vehicle is restored to optimal driving conditions. Preventive maintenance plays a vital role in avoiding the recurrence of DTC's P219C, P219D, P219E, and P219F. Regular sensor checks should be part of routine maintenance, as air-fuel ratio sensors are crucial for efficient combustion. Ensuring they are in proper working condition can prevent issues before they arise. Inspecting fuel injectors periodically can also help avoid fuel delivery inconsistencies. And any signs of wear should be addressed promptly to maintain optimal performance. Furthermore, monitoring overall engine performance is essential, especially observing any changes in fuel efficiency or driving behavior. Early detection of minor issues can save considerable repair costs while ensuring the longevity of the engine. Adopting these routine maintenance practices creates a proactive approach to vehicular care. In conclusion, understanding DTC's P219C, P219D, P219E, and P219F is crucial for maintaining the Honda CR-V's engine health. These codes reflect significant issues related to air-fuel ratios, directly impacting the vehicle's performance and emissions. Identifying symptoms early allows for quicker interventions, preventing minor issues from escalating into major repairs. Following systematic troubleshooting steps ensures accurate diagnostics and effective resolution of air-fuel variations. Furthermore, implementing preventive maintenance strategies can mitigate future occurrences of these DTCs, keeping the engine operating efficiently. Overall, a comprehensive understanding and proactive approach to these diagnostic codes will enhance the overall reliability and performance of the Honda CR-V. Please like and subscribe to the channel. See you next time.